Good day folks, I hope you guys are fine. So here it's a small video about project explanation. So in this project you will use system identification using dynamic simulation and HYSYS. So it's in this project we will talk about the personality of the system and we will explore the personality of the system, like either it's first order system or second order systems based on system identification technique. For this, please read this through and I will explain you how to build this simulation. So it's simple, and I will simulate one tank and you can follow the steps for the other tanks. So let's build this simulation. First of all, as usual, add components, water, and nitrogen and oxygen for air. You can add air as well, and oxygen. After that, you can use any suitable fluid package, like for example, I think Bang-Robinson will work for this system, because this is just like a simple physical system, no chemical reaction is involved, so Bang-Robinson will work. Others will work as well. Now go to simulation, and here you can see a tank. So first of all, bring that tank here, rename this, do the connections. This is feed 1, this is vapor 1, and this is liquid 1. So now connections are done, as you can see that. Now I can add composition or conditions for our feed as given in the statement. We have 15 degrees Celsius temperature, 1 atm pressure, molar flow is 20 kilogram mole per hour, composition is water which is coming in. Now this simple steady state tank is solved, as you can see that here. So it's simple and straightforward, right? So remember this, liquid is coming in through this tank and liquid is going down is in L1. V1 is open to atmosphere, that's why we added air, nitrogen and oxygen, so that if there is a backflow, here in backflow we should have oxygen and nitrogen or air because it's open to the atmosphere. Now the volume is mentioned of this tank, so we can mention the volume as 2 cubic meters. Now we are ready for dynamic simulation. I will recommend you guys here to save a always save a steady state case before moving to dynamic. Now let's go for dynamic specs first, because feed 1 or F1 is connected with a capacity system tank, so we can use flow spec, and L1 is also connected with, L1 is a boundary stream, F1 is a boundary stream, and V1 is a boundary stream. Because L1 is also connected with a capacity system, so I can use a flow spec here. And V1 is connected with the capacity system, however, because we are expecting a gas here, air, because it's open to atmosphere, that's why I will use, or I will prefer to use pressure spec here, because otherwise there will be liquid flow in this direction as well. We need to change the composition once we are in dynamic, so we cannot do that now, so we will do that once we are in the dynamic. We will give the composition of air. Now I presume that it's very much ready for the dynamic simulation. Just in case, we can check the dynamic assistant, and as you can see that there is no further changes required. Now we can go to dynamic mode. Yes, we are ready for that now. And once you are in dynamic mode, now you can add a sheet, a spreadsheet here to develop the personality of the system. So maybe I can put that here. So this spreadsheet is just like an Excel sheet. So what you're gonna do is double click on this. So you will have something like this. Go to spreadsheet and it will behave like an Excel sheet now. Here what I will do is liquid level of this tank. I will copy that here in B1. So for that, click on B1, right click, add import variables. You will have something like this pop-up window. Now you want the tank level, tank liquid level here in this Excel sheet, and you want the liquid out of the tank, liquid out of the tank L2, L1 is equal to whatever is in B1 liquid level multiplied by a number which is given in the statement. I'm using 20. You can use any number between 0.4 to 30 because I'm now implementing equation number 1, which is for a linear valve. So head is basically liquid level, K is the value which I'm entering as 20. So for nonlinear valve, you can use head and square root of that. Now I got this. Now click on this B2, which is my output variable. Right click on this. I want to export this result, and this result should go to L1 molar flow rate because that's what I want, right? Molar flow, select. Now my spreadsheet is ready. I can just run this for a minute, so see if it's working. So now you can see that it has got the number liquid level. Double click on this. I just want to show you. So here it's a liquid level or height or head, and I have multiplied that by 20. I got this, and this is what I'm getting here. In this case 35.79, exactly as it's given in the Excel sheet. Now another thing which we need to mention clearly here, because now we are in dynamic mode, so we need to specify the composition here, because now here's composition of water which we don't want. We don't want water here. We want air which is around 80% nitrogen and 20% oxygen. So the purpose of this composition is if there is a backflow in this V1 which is open to atmosphere, so that should be the composition of air, right? Because otherwise liquid will start going in this direction. Now the simulation is very much ready and set up. Now we can go to strip chart because we want to observe the behavior. Add a data logger. So for the better view, I will recommend logger size around 50,000 and sample interval of 5, and maybe you can have integral or integrator acceleration 0.1. So I think these numbers will help you to visualize the thing in much better way. Now go to edit. Now you want to add variables. So you want F1, which is your feed, molar flow, and you want to observe L1 molar flow as well. So F1, which is your feed molar flow, it's your input, and L1 molar flow, that is your output. Now you can see that I have added both variables. Now you can display this strip chart. So you can change the color if you like, and you can also change the thickness of the curves so that you can visualize that in a much better way. Now I can run this simulation, auto adjust all the axes. So now you can see that it's working. So for the personality test, you can see that it's coming close to this. So wait for this a little bit. Now once it's at steady state, you can give a step input in flow rate to observe the behavior in the output. So let's say I put 30, and you can see that the 30 is your feed 1 flow rate, and green is your response, which is at the output, right? So you can see that you are fudging or getting first order response, which is very much similar to this one, as you can see in figure number 1. Now for second and third order or second order types, what you're going to do is, using this Excel sheet again, whatever is input here in L1, put this input for the next tank, like this in this picture. So if I can focus on this picture, L1 flow rate should be copied here for F2, and the same thing you will apply here for L2 as you did for tank 1, and V2 as well as you did for tank 1, and L2 would be equal to F3, and the same philosophy you will do for V3 and L3 as you have done in tank 1. And then here you will add, with these two parameters in the strip chart, you can add L2 and L3, and then you will observe second and different types of second order response as well. I hope this video is clear enough for you guys, and if you have any question, you can consult me. Thank you very much. Good luck.